Okay, yeah, we are recording. Welcome everybody to the Android Automotive Special Interest Group Technical Workshop at the all-member meeting. The agenda today is to cover vehicle HAL and audio HAL in short time, so I will turn over to Stefan at TietoEvry immediately, and I think we get started on the vehicle HAL discussion.
Okay, so shall I share the screen and start, or we need to wait a couple? Okay.
It looks good. It's in full screen.
Yeah, perfect. So, hello, my name is Stefan. I'm an engineer in TietoEvry, working together with other automotive, Android Automotive SIG participants in regards to vehicle API project. Okay. So as you might be aware, the task for integrating Android Automotive in our in modern cars is to make a certain set of vehicle signals available to the applications by using the specific API that is designed by Google. So they published some SDK that is available for the third-party developers to develop their apps. They created their own format of describing the signals, which is called the vehicle properties in Android. The usual task for the new platform is to bind somehow your own or OEM own proprietary signals or CAN messages and translate it into the Google defined format, which is pretty much proprietary for this, so it cannot be reused in other operating system. That's when VSS comes to play. So we want to unify it a little. So the goal of our work is to make the VSS formatted, let me say, signals available by providing some kind of translation unit that is running inside Android and is laying in the vehicle HAL component that enables the way or automatically translation between the VSS to the Android structures. So the unit should be easy to maintain because most of the maintenance cost is moved to GENIVI and W3C to maintain the VSS format. And of course, it can be split between different operating systems that uses the same format as for VSS. So here are the two examples of the format that we want to translate from and to. On the left, there's a known VSS, and the second one consists the definition on the Android side. So as you can see, we can find some similarities. So based on that, we could at least guess or predict how those structure from one standard to another can be translated, let me say, or generated into other structure. So in our implementation that we are going to show, we have chosen different signals that represents different complexity of translations. We have some very trivial one, but like without any conversion, like from Boolean to Boolean value or from float to float. We have some more, let me say, challenging for the VSS and Android format, like more than one entities. For example, when we have tire entity that is have more instances than once, and Android has different way of accessing such stuff. We have other property or signal which needs to be translated from kilometers per hour to meters per second. So VSS is right now defining the format for kilometers in Android as meters per second. And the most complex one, which is the level on VSS, it is described as a percentage of the fuel fuel tank. And Android expects to have the values in milliliters, which means that for conversion we need to be aware of the whole the tank capacity. Yeah. So based on that, we've achieved the mapping. It is done with an input from Melco, which is also contributing to the VHAL projects and manually map the Android properties to the VSS and analyze the kind of translation is needed. Some values are fetched from VSpec and some are from types, and based on that we were able to create some kind of a translation map that allows our translation unit that runs inside vehicle HAL to translate those properties into Android format and make it exposed to the third-party applications in that case. So that's the idea. We have some let's say VSS feeder, which is in our case is a simple server that listens on the socket for VSS data that is encoded in the, for example, in CSV format, which is actually just for the demo purposes, easy to read and easy to show the idea. Our custom vehicle HAL uses some internal map that is actually based on the XLS contribution, and use it to translate from VSS to ASP format. And then the property which is already translated to ASP format is available to the Android framework and to the end user applications. So I will show the actual demo of the implementation. I'll give the voice to the colleague who has recorded the video. So listen. Okay, yeah.
I will be showing converter between vehicle signal specification, known as VSS, to Android properties format. So here we have the Android emulator, and let's now go to the kitchen sink app and check some value, for example, ABS active. Currently, this is set to 0, so basically false. And we will try to change this value to true using the VSS, basically. So let's start first with going to Android shell. And now we will use netcat. With some defined port that is used by the underlying code. And now we will change this value. And the format that will be used is, of course, basing on VSS. Okay, so already at this point, the underlying code parsed this CSV basically, and change the VSS property into Android vehicle property. So now we can go to the emulator and check again the ABS active. And now you see the 1 here. So basically the value was changed. Of course, we can change it back to false. And it will be 0. And there are already some other properties implemented, like, for example, engine oil. So let's check maybe the engine oil value, engine oil temperature. So currently it's 101. And let's change it to 76, for example. So yeah, this is basing again on VSS. And now let's set value to 76. And check again in the emulator, and we have 76. What else? Maybe let's go to fuel level because it's a bit more interesting. Currently, fuel level is set to 15,000 milliliters, and in VSS there are no milliliters, but instead there's percentage of the tank. So let's now change this fuel level to something that is recognizable by VSS. So we will be changing this level to 87%, right? So after doing that, we can change fuel level. And as you see, it's something like 13,000 milliliters. So the percentage was converted to the milliliters by the underlying code. And yeah, basically this is it. We already have some other values implemented, like vehicle speed, like tire pressure, and so on.
Okay, so just a quick summary, because we have a couple of minutes left. So basically, this is the idea how the implementations looks like. We have mapped in the code the VSS identifiers with some translation methods. It can be generic ones, like for example, if we only need the linear translation that we need to multiply by some value of r at some constant, we could create a utility method for translating those, or for the more let me say more complex one, like for example for the fuel level, we could make our automation tool during the build time create some kind of stop method that developer can implement it by their own, or use this linear translation as it's shown here. So I welcome you all always for the next workshop, which will happen tomorrow, when we going to discuss more about the future of it. I have some couple of ideas how to proceed with the automatization or automation for those. For example, introducing some kind of meta language that could be used for describing such complex complex translations, instead of just automatic the trivial ones, like one-to-one or from linear to some others. So based on always, of course, we have our weekly telcos that happens on Tuesdays at 5 p.m. European time, that we'll going to proceed with such translations. If you have some blogs already implemented, or you have some thoughts, you're always welcome to join. So that was all from my side. Thank you.
Thank you very much, Stefan.
I don't know if we have time for a question now, or shall we wait until the end? Or if no, then
I think we might as well maybe wait until the end. unless there's an immediate question, and go to Piotr, talk a little bit about audio, and then we may collect all the questions at the end. I don't see any questions in the chat, at least. Piotr? Are you there? Are you muted?
Even double muted.
There you are.
Yeah, so I am here, so let me share. So hello everyone. My name is Piotr Krawczak. I'm working as a software engineer in TietoEvry company, and let me share with you some thoughts about audio HAL and the proof of concept and that we were working on, and what we could work in the future. So we were actually focusing lately on a virtualization case, and especially we focused on a Trout project from Google. To those who are not familiar with this, it is Trout is kind of a virtualized Android project. It is based on a cuttlefish. That is a reference platform for virtualized Androids. All the HALs are virtualized there, and you can run it in a virtual machine out of the box. At least that's the idea. Together with a cuttlefish, there is also a bunch of host tools, especially for x86 machines. There is CrossVM, which is a virtual machine manager, dedicated to run on x86 machines, dedicated to run actually Linux platforms written in Rust by Google. So the HALs. So within the Trout, you can find following HALs. They are implemented in a virtualized manner. They are mostly basing on VirtualIO specification standardization, which seems that Wysocki is being used the most. So the functionality is actually a bit limited of the Trout HALs due to HALs that are in a pass-through mode. This actually relates to communication devices like Bluetooth or Wi-Fi, GNSS also. So this is kind of a hardware specific, and there is no standard HAL that can be written in a virtualized manner, at least for the moment. So as maybe you noticed that on previous slide there was no audio HAL, and the reason behind is that basically there is no currently available audio HAL for a Trout. The audio HAL that you can find in the sources is something that is basing on an emulator HAL and is referring to the ALSA devices, to the PCM device, and actually is causing Trout to crash. So first thing, if you would like to run Trout, is to actually somehow patch the audio HAL to stop referring it to the ALSA PCM device, which is not available in cross VM implementation. So the possibilities, this is obvious possibility for us to have some work on it, and the possibilities that we currently see is that first of all, seems to be most natural is this virtual sound specific device specification, but it is coming in virtual 1.2 specification, which is still in draft. It is available on GitHub from Oasis group. You can check how it is working, but it is not yet published. However, there are drivers for the kernel for virtual sound available. They are not yet merged to the but waiting in a preview queue, but they are working and you can take it and use it. On the cross-VM side, there is no device implementation yet. Maybe it will be in the future. So for this moment, there's no ready way to use virtual sound. But what is actually ready is the Wysocki implementation. The Wysocki is up and running. You can use it, and it is already used by other HALs. And for the communication within the same hardware, the Wysocki communication for the audio purposes seems to be working quite fine. Other alternatives could be WebRTC stack or AVB. But for our purpose, for this moment, we actually focused on the Wysocki. So how the Trout is actually deployed. So as I mentioned, the Trout is delivered with Cross VM, which is virtual machine manager dedicated to running Linux operating systems. It requires KVM support from the kernel side, and it is able to run the Android that can be built from the sources on the KVM manner. It provides some device implementations. It supports Virtual in 1.1 specification, so it exposes Wysocki, for example, interfaces and many other, but yeah, again, not yet Virtual sound. Of course, this implementation can be extended by ourselves. We can add the device implementation. You can also add any custom device based on VirtuQ, as Google VM, which is written in Rust, provides this VirtuQ implementation, and it is working quite nicely. You can easily add your custom device to communicate with virtual machine if you are interested in. So possible deployments for Trout could be even some kind of a real hardware, but from our perspective, the most interesting thing is that on the one ECU, you can deploy a Trout in almost untouched way, but because of the virtualized HALs, you can deploy then Linux virtual machine consisting of device implementations that will interact with the HALs. The communication will be served by hypervisor of chosen brand, and you can connect it to external amplifier. With such a setup, the Trout is kind of an Android that is almost completely hardware independent and can be quite nicely switched from one hardware to another. That's the idea. Maybe this is kind of an utopia, but still, this is quite nice idea. So for our proof of concept, we decided that we will use this Trout and try to explore its possibilities and try to send the audio data to some external entities living outside of VM, and most possibly also somehow isolated from the host. For this purpose, we used the Wysocki communication for the between Trout VM and the host, as the virtual sound is not yet available. However, it seems to be natural choice. We added some receivers on the host side, not only for the audio data, for the PCM audio data, like here, but also for other parameters like gain, fader, balance. And what is interesting in the Trout, it can be controlled via embedded HTTPD server embedded within the Trout delivery. So you can actually see the UI and you can control the UI via browser. So we extended somehow this control mechanism and allowed it to read the gain, fader, and balance values via WebSocket from the Trout VM. So let me show you how it works. Actually, I have a short flip for you. So here you can see this this interface that I've mentioned. It can be accessible from the local host, and the HTTP server is actually embedded within the Trout VM. And yeah, as you can see, there is UI. Here is the part that is responsible for the control. The first three buttons are actually the standard one provided by the Trout implementation. The three other are our extensions. Currently it shows nothing, but they will show something later on. So the audio is transferred via PCM data, and the solution actually that we used for this is almost the same as we used for previous proof of concept, that we are trying to get the raw PCM data from the Android VM. We were doing the via socket. Now we are just using Wysocki, so it's no-brainer here. So the audio can be heard easily. And what is maybe more important from the, let's say, external amplifier point of view, the values like gain can be read also from the Android, and easily passed to the external amplifier for further processing. So as you can see, we can control, we can check balance, fade, and gain here from this browser UI. So that's for the demo. And our actual, what could be the next step out of it is I already mentioned WebRTC protocol that can be used for transporting not just the video that can be seen with this chart implementation, but also audio. And the idea behind is that we can create kind of an environment for cooperating between parties like tier 1 and effect suppliers, noise cancellations and echo reductions of manufacturers, so that can easily exchange the Android virtual machines between each other and test their, let's say, audio solutions. What we can add also to this proof of concept is to visualize so the backward communication, so transferring the volumes back to the Trout from the browser UI. What is also interesting would be to expose interface for enabling audio effect and applying them on the audio stream. Maybe connecting them to the audio effect interface from Android, so that the information about applied audio effects from audio HAL can be then transported back to the external amplifier for execution. There are many ways and that we can follow from it, and I guess that we need also your feedback, what would be interesting and what you think would be worth investing more time and efforts to check. So that would be all from my side. Thanks for watching and waiting for questions.
Yeah, questions or comments from those of you who are online?
I think there was some questions from the chat. Am I right?
I don't see any. Here's one.
So is it necessary to encoded audio once you get PCM data to audio HAL using sockets? For the transport, we were not using any encoding to decrease latency and to make things easier. But if there is any need, if there is a use case for, let's say, distant communication, an encoding can be applied, and something like a G-stream pipeline also can be applied here to achieve kind of a remote projection. Next, what is the commercial use case for the audio POG? I think that we were discussing this kind of a collaboration model. So that, for example, the tier one is able to work on their platform on the UCU and provide it in a kind of a virtual machine package to the let's say other company that is responsible for developing audio effects on their hardware. Do you already have an idea on the latency from Android to an AMP? Well, this mostly depends on the hypervisor solution. So if for Wysocki, the latency could be significant, as there is some overhead for the transport layer. But with additional effort, you can implement your own handling based on VHQ. That could be actually zero copy solution and could be quite fast, as the VHQ are basing on descriptors that are shared between virtual machine and the host system. Or we can wait for the virtual sound specification that should also allow. Actually, I believe that it is already available from commercial implementators. But for the future sound, also zero copy solution could be achievable, and the gateway to for example AVB or other audio bus can be achieved with low latency. At least I believe so.
Yeah, the specification itself has been merged to the master branch of Virtio, so even if there isn't a versioned release of that document, it seems generally accepted and stable at this point, the Virtio sound.
Yes, it seems that there will be no major changes, or maybe not even any changes. But yeah, still, it has a status of draft. But seems to be stable, as you mentioned. Yeah, that's correct. So, any additional questions? Or maybe ideas, if you like it or not, or maybe you can share some thoughts about it.
Any questions on the application of data from VSS as the proposed standard data model and integrating Android there? Seems very clear to everyone.
So I will give back control to you, Gunnar. Thank you.
Yeah, thank you very much, Piotr. So that is the last topic for today. We have a workshop tomorrow, as been mentioned, with a more open agenda. So I hope you'll join us, and we have perhaps some deeper discussions of these topics. And from that, we can distill the kind of future-looking planning as well. That's the idea with the workshop tomorrow. Okay, then that wraps up our workshop for today. Thank you to everyone who's been participating, and hope to speak to you soon.
Thank you so much for a great presentation.
Thank you. Bye.
Thank you very much.
Bye-bye.
Thanks. Bye-bye.
Thanks. Bye-bye.